Hi, how's it going? Welcome to Code with Z. In today's video, we gotta go from this array that we were given to these subsets. Why? Well, because that's what LeetCode 78 subsets is asking us to do. Now, as you can see, it says, given an integer array called nums of unique elements, return all possible subsets. The solution set must not contain duplicate subsets. Return the solution in any order. Awesome. Now let's see what this even means. Let's kind of translate this. So we know we need to return subsets, but what is a subset? Well, if this array was given to us by the question, a subset is any smaller group of elements that we take from this array that we have here. So for example, we can take 1, and this is going to be a subset because this is a smaller group of elements that we took from our bigger group of elements. This is our original group of elements, and we just took 1 out of it, and this is going to be a subset of this. Now, 1 and 2 can also be a subset because, again, we took 1 and 2. These two are the smaller group of elements that we took from our bigger group of elements. Or we could even have 2 and 3 for the same reason. But you saw that we had 1 and 2, right? If we actually get 2 and 1, these two, even though they're both subsets, they're considered the same thing because we're not looking for permutations, we're looking for subsets, and 1 and 2 or 2 and 1 are considered the same thing, like the order does not matter. So even though these two are subsets, they're considered the same. So when we actually return the subset and when we actually try to find the subsets in our code, we gotta make sure that we don't treat these as two different subsets because they are treated as one. Alright, we can also have an empty subset. This is also a subset because we just chose to not take any elements from our large group of elements. And this is also considered a valid subset. Okay, now we know that, for example, 1 by itself could be a subset, 1 and 2 could be a subset, even 1, 2, 3 could be a subset. Awesome. Now let me bring this here and let's see how we can solve this. We're going to use backtracking. Why? Well, because we're looking for all of the possible answers. And usually when we're looking for all of the possible answers, for example, we want to see how many subsets we can have if we start with 1, or how many subsets we can have if we start empty, or like how many subsets we can have if we start with 2, or maybe how many subsets we can have if we start with 1 and then add the number 2 to it. How many subsets can we have after that? So because we're looking for all of the possible answers, we need to use backtracking. So in the beginning, when we actually look for our answers, the result that we're going to have is going to be empty, meaning when we start, we've not found any answers. So we're going to start from an empty array and then we gradually add numbers to it and explore the possible subsets that we can have. All right, we're going to be like, okay, we have an empty array. What can we do here? Well, we can either explore adding 1 to our array here and explore all of the possible answers that we can have if we start with 1, or we could just start with an empty array, meaning we could just have the empty array here and not add 1 to it. Because remember, we could also have an empty array as an answer, right? So let's explore those. We're going to be like, okay, let's see what will happen if we add 1 to this array here. As you can see, 1 is added to the array that was empty in the previous stage. And we can also be like, our array is still empty and we've not added any numbers to it. So here we're exploring what subset are we going to have if we don't add any numbers to our array. So let's explore these two possible scenarios. We're going to be like, okay, if we add 1 to our array, what else can we do? Well, we can add 2 to it, or we can keep it as it is. So we can actually be like, okay, let's add 2 to our array. As you can see, now 2 is also added, or we can just be like, let's leave it as it is. As you can see, each time we're going to have two decisions to either add a number to it or to keep it as it is. Well, if we add 2 to this, we're going to have two possible other scenarios. You tell me what they are. The first one is going to be, well, if we add 3 to it, and the other one is going to be if we keep it as it is. Now, if we keep on exploring, we're going to be like, okay, let's explore this further. When we try to explore this one further, we're going to be like, oh, we are 3 levels deep inside of our tree. As you can see, 1, 2, 3. So when we go as deep as the length of the array that we were given inside of our tree, we can actually consider whatever we have as a result. So 1, 2, 3 is actually going to be one of our answers, and we're going to store this. Why did we actually stop here and we did not explore further? Because as I mentioned, we're going to go as deep in this tree as the length of our array that was given to us. The length is 3, and we went 1 level, 2 level, 3 levels deep. As you can see, if the length of this was 5, meaning we had 1, 2, 3, 4, 5, we would go 5 levels deep. And that's how we know when we should stop, because in backtracking, we got to have a base case that will tell us, okay, if you reach this stage, stop and store whatever you have. And this is what we're doing. So we're going to be like, okay, we've stored this. So let's go back, we backtrack, and let's check this one and explore this one further. But when we also want to explore this one further, we're going to be like, oh, we're already 3 levels deep. So we can actually consider this as an answer as well, and we're going to store it. So now we have 2 answers. As you can see, this is a subset 1, 2, 3, and this is also a subset 1, 2. And then we're going to be like, okay, let's backtrack and come back here and explore this one further. For this one, we can have 2 possible scenarios. We can either add 3 to it, because as you can see, we've already added the number 2. So we're not going to add number 2 to it because that's going to give us a duplicate. So we're going to be like, okay, we can either add the number 3 or we can just keep it as it is. Now we want to keep on exploring this one further, but again, we're going to be like, oh, we're already 3 levels deep, so we're just going to store this as an answer. And as you can see, this is also a valid subset. Then we're going to be like, okay, let's explore this one further, but again, same thing. We're as deep in our tree as the length of the array that we were given, so this is going to be our answer as well. So now we have 4 answers. We're going to be like, okay, we can't explore any of these further, so let's go back and explore these. We're going to be like, okay, here we were like, the reason we reached this stage was because we were like, we could either add 1 to it or keep it as it is. Keep our empty array as it is. Here we have 2 other options. We could be like, we could either add 2 to it or we could keep it as it is. And it makes sense. In the beginning, we were like, we could either add 1 or keep it as it is. Now this is going to explore the possibility of adding 1 to it. And then here we're going to ask again, we can either add 2 to it because we've already added 1, and this is going to explore all of that possible scenarios. So here we can explore adding 2 to it or keep it as it is. Well, if we add 2 to it, we can have 2 possible scenarios. We can either add 3 to this as well or keep it as it is, like so. Now, if we want to explore this further, we won't be able to do that because this is a valid answer and we're already 3 levels deep. So we're going to keep this as an answer as well. And then we're going to come here to explore this further. But again, for the same reason, we're going to be like, oh, we're already 3 levels deep. So we're going to stop. And this is going to be one of our answers as well. So we're going to come back here. And here we're going to be like, okay, we can either keep this as empty or add the number 3 to it. So we can either add 3 to this or keep it as empty. And as you can see, the same thing just keeps on happening. For all of these stages, we can either add a number to it or keep it as it is. So here we're going to be like, okay, let's explore this one further, but we're already 3 levels deep. So we're going to store this as an answer as well. Let's go back here and we want to explore this further, but we're already 3 levels deep. So we're going to store this as an answer as well. And this is going to be all of our subsets that we can have, as you can see, and we're going to return these inside of an array. So each time when we actually come to an answer, we're going to store this answer inside of our result array. And then at the end, our result array is going to have all of these inside of it. And we're just going to return it at the end. Now let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we need to do is to define our result array like so. And this is going to be having all of our answers inside of it. And then at the end, we're going to return it like so. Now between these 2 lines, we're going to have our backtracking function. We're going to say function backtrack like so. Now, when we call this backtracking function, we're going to give it 2 variables. Like so, we're going to say backtrack 0 and an empty array. Now, what does this mean? Well, 0 represents how deep we are inside of our tree, and this empty array is basically the empty array that we started with. So as you can see, 0 is going to be called index, and that empty array is going to be called current array. Like so. And this current array is going to be like the array that we're going to add numbers to it. So just like you saw, we added 1 to it. Then we were like, what if we add 2 to it? That's this array. And this is representing how deep we are inside of our tree. Because we're going to say, literally, our base case is going to be if index, which is basically this 0 in the beginning, and then it's going to get incremented. If index is equal to nums.length, meaning if we're as deep in our tree as the length of our array, we want to store the answer and stop exploring, just like we saw on the slide. So we're going to say result.push of current array, because that's the array that holds the answer, and we're going to return like so. Now, I want you to know, now that we have taken care of the base case for our function, we need to see how we can actually add numbers to our array, explore those possibilities, and be like, you know what? Let's actually remove this number and exploring the possibility of starting with another number. For example, if we add 1 to our array like so, and we want to explore what will happen if we start with 1, we also want to be like, let's remove 1 and test what will happen if we start with 2, like so, just like we saw on the slides. Or even when we actually add 1 to our array, we're going to be like, okay, we know we're exploring what will happen if we start with 1, but I also want to know what will happen if I start with an empty array, like so. So for doing this, we're going to use our current array because this is the array that's going to have all of the numbers. We're going to be like, okay, let's explore what will happen if we add 1, for example, to our array. So we're going to say current array.push, and here we're going to push nums at the index that we have. Now, why index? Well, as you saw, we said that index basically tells us how deep we are inside of our tree, but we can also use index to get the numbers that we have inside of our numbers array that was given to us. So index has 2 roles. Here it represents how deep we are inside of the tree, and here we can actually use it to get the numbers that we have inside of our array. Now that we've added the number to our current array, we want to explore that possibility. So for example, here we're exploring what will happen if we start with 1. So let's call our backtracking function, and we're going to give it index plus 1 and current array. Why? Well, current array is obvious because we added the number to our current array, so we want to know what will happen if we actually start, for example, with 1. So now that we've updated our current array, we're passing it to our backtracking function to explore that possibility on its own. So we're sending the function to do the exploration for us. And the reason we give it index plus 1 is because we're going to dive 1 level deep inside of our tree, and we don't want to have the same number added to it. So for example, we don't want to add the number 1 twice. And because here we say index at the index of nums, meaning we're going to get the number at the position of index inside of our nums array, we got to update it so in the next time we're not going to have the same repeated number. So for those 2 reasons, we're going to say index plus 1. Now, if you remember, we had 2 options. We always said what will happen if we add a number to our array and then we explore that possibility, but we also said what will happen if we don't add anything to it. So we're going to say current array.pop, and this is going to empty that number that we just added, and we're going to call our backtracking function again, and we're going to say index plus 1 and current array. This is basically saying add a number to our current array, explore what will happen if we actually add that number to it, and then we're going to be like, you know what, let's also explore what will happen if we don't do anything. So remove the number that we just added and explore what will happen if we don't add anything. That's going to be it. Now, believe it or not, we're done with our backtracking function. The only thing that we need to add is that when we actually push our current array inside of our result, we need to make a copy of it instead of pushing it directly. So the only thing that we need to add is to make this a copy of the current array. So we have the same array, but it's a copy that we're going to add inside of our result. And then at the end, when we call our backtracking function, our result array is going to be filled with answers, and we're just going to return it. Now, let's run this and see if we're going to get accepted. I hope I have not made any typos. Moment of truth. Okay, we passed 2 cases. Now let's see if we can actually pass all of the test cases. Drum roll, please. Just kidding. Let's see. And awesome. We got accepted. Thanks for watching. Don't forget to like and subscribe and keep on coding.